Hello, I'm Alec Bowman,
And I'm Ryan Grossman.
and our CS51 project was to design a program that could play checkers against humans and learn from its playing to improve its strategy.
The two main algorithms we use are first a neural network, or an artificial neural network, that is designed in the style of a human neural network. And it works by building a collection of nodes that passes up to another level of nodes and keeps passing up until it reaches one final node. And the first set of nodes gathers data about sort of the state of the situation, and the second set of nodes and the higher levels run a function on those nodes, multiplying things by weights and adding different factors in until they output a value at the end. And then using that value, the final node makes a decision. So in our case, we had a base set of nodes that represented all the pieces on the board, or all the various squares on the board, and they would return information about the number of kings, the number of pieces, and a variety of factors such as the location of pieces, up to higher levels, which would then use a series of weights, run a function on them, and this would occur for each possible next move for the computer. So then, after the function ran through all these next possible moves, the one with the highest value from the function would be picked and that move would be made. The second algorithm we used was a temporal difference learning algorithm. This algorithm works um, by after a game is finished, if it's a win, a loss, or a draw, it will look at what occurred during that game. So if there were a lot of kings at the end or something like that, and it will go through and update the weights of the neural network based on what it found happened in that game and whether it had a positive outcome, such as a win, or a negative outcome, like a loss.
All right, I'll play for a little bit. The first challenge that we came up against was designing the interface, the graphical interface in OCaml, to make sure that both players had to play by the rules. And you can see that they do. When you have to make a move, you are forced to make a move. Or when you can make a move, you're forced to make a move. Or else you can make a regular move. So there you have it.
Um, Overall, evaluating the program we wrote, we found that through other research and our own trials that checkers is a very hard game for computers to learn because there's not enough variety in the possible types of moves. So it takes it a very long time to be exposed to all the different situations, and a lot of situations won't really occur in normal play. With that being said, all our algorithm runs and works and updates well, and the learning period did give some fruitful results because we found after we ran and learned and updated the weights that it did play better than when we just used random weights.
All right, thank you.